Alright, the way that I'm gonna do this is just by going through and explaining my exact thought process. So I'm not gonna stop this video or anything. I'll probably cut it up later so I can actually upload it. But here we go. So this is like the first time I'm reading it since like 2 weeks ago. For t between 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by this velocity function, so I know velocity. I guess I'm just going to write down stuff. V of t, I'm given that. I know the velocity, and that's cosine of pi over 6 times t. I'm just writing stuff down. The particle's position at 2, the particle's position at 2. Okay, so that's denoted by s of t. Well, I don't know what that equation is, or that function, but I do know that at x equals -2, the position is, the position is x, so I guess I should say x of t. This is my exact thought process. The particle position x equals -2. No, I'm just going to leave it as s. S of t, I don't know. S of time is what I'm inputting. Some people might have gotten confused, like, oh, wait, do you plug in the x or do you plug in the t? Well, it's telling me that it moves along the x-axis, so the x is actually the position. It's like the output, so that will be -2. Okay, so this is just information. Part A, so I guess I can start thinking about A. For t between 0 and 12, when is the particle moving to the left? Moving to the left, that's like backwards. That's also asking me when is the velocity negative. So I would actually write that down. Because that means moving left. So I would actually write all that down. And then I'd say, okay, well, how do I figure out when velocity is negative? I can take the derivative and make a sign chart. It doesn't ask me to explain, it just needs an answer. So when is velocity less than 0? So I guess I could take the derivative. No. Why do I need the derivative? Let's see. I don't need the derivative of velocity. That would give me acceleration. I don't want to know when the acceleration is negative. I want to know when the velocity is negative. So I'll just make a sign chart. Set it equal to 0. Cosine pi over 6 times t. And then I'm going to say let theta equal pi over 6t, because that's kind of weird to think about. So now I'm thinking about when is cosine of theta 0. Well, on the unit circle, cosine is the x-coordinate, so it said from 0 to 12. That's kind of weird. Well, I know that here at theta equals pi over 2, that's what I'm looking for, because cosine is 0, and theta equals 3 pi over 2. Those are both when cosine is 0. Okay, so that's what theta is, but I want to know when t is, so I'll just say, well, first time it happens is when theta is pi over 2. But that's the same thing as saying pi over 2 is equal to pi over 6 times t. I'm just substituting in my theta. Alright, and I'll multiply by 6 over pi. So t equals 3. Does that work? That fits in my interval. Okay. The second time it happens, so that's one of them. The second time it happens is when theta is 3 pi over 2. So that means 3 pi over 2 equals pi over 6t. Multiply by 6 over pi. So it'll be 9 equals t. And then, well, the next time this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. If I put in 5 pi over 2 for theta, let's see what I get. That would be equal to pi over 6 times t. I'm hoping this is probably bigger than 12. So I solve, again, same way. This would be 3, that would be 15. So that doesn't count because they're only asking for t between 0 and 12. And I don't go negative because then that would make my time negative. So those are the two answers. When is the particle moving left? I would write down a sentence. Oh, actually, wait, that's not my two answers. T equals 3 and t equals 9, those are my critical points for the function. So I still need to make a sign chart. It's a good thing I read the question again. This would be 3 and 9. Let's say sine of velocity. Maybe I will make separate videos since this is just my train of thought. And then test points. I'll plug in, well, I can be 0, 3, I can be 4, and then I can be 10. Well, actually, that's test points. TP, not toilet paper. Okay, so the sine of my velocity, when I plug in 3, well, my velocity function is v of t, that's just cosine pi over 6 times t. So if I put a 3 in there, those will cancel, and I can just get pi over 2, right? Just to make sure. Yeah, divide by 3, I would get 1, and then this would become 2. So it would be cosine of pi over 2. I already know cosine of pi over 2 is 0. What? Oh, I wasn't supposed to plug in 3. That makes sense. If I plugged in 0, I would get a positive, right? I don't know why I plugged in 3. You're not supposed to plug in your critical points. You already know that your function equals 0 there. That's how you got them. So I'll plug in 0, and I get cosine of 0. That's just 1, so that's positive. If I plug in, maybe I'll plug in 6. That way it cancels out. I'll change that to 6. 4 would be just as fine, but 6 is easy because if I plug in a 6 here, it would cancel out. And I just get cosine of pi, which is negative, right? Negative 1 to be exact. And then cosine of 10, well, let's see what happens. If I plug in a 10 here, divide by 2, this becomes 5. Divide by 2 is 5 pi over 3. Where is that? This slice is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Wait, is that right? 4 pi over 3? Yeah, 5 pi over 3. So cosine is negative there in that quadrant. Sorry, positive. Right? Cosine is the x-coordinate, so cosine is positive. Sine is negative, that's what I was thinking of. Okay, so when is the particle moving backwards? When is the particle moving left, actually? And that's between 3 and 9. I know that at 3 and at 9, the particle's not moving at all. It has a velocity of 0. So my sentence and my actual answer would be the particle is moving left between t equals 3 and t equals 9, not including 3 and 9. So that's part A. That's my actual answer, and I would say I cross that out, and move on. I wouldn't be explaining all this stuff, but it took about, I don't know, 8 minutes, 6 minutes, 7 minutes. I'm done.